Okay, you guys. I was looking through some work that was already turned in to me, and we need to go over how to make a graph when given a table. I was going to do this in a Google Meet today on Wednesday, but I thought it would be easier just to do the video because with my Google Meet, sometimes my computer freezes up, and then it's hard for me to hold the paper up to the camera. So I'm just going to show you how to do that in this video. So I'm going to be working through assignment 6-2, and I'm looking at problem 3-34 to start. So let me show you what that problem looks like in the book. So if you want to grab your notebook, pause it, grab your notebook, piece of paper or something so that you can work this out with me. That way you have an example for the other ones I want you to do. Okay, so for 3-34, they give you this rule. It says use the rule y equals 2x plus 1 to complete parts A through C. So the rule they give you is y equals 2x plus 1. They give us the rule in algebraic form. When you were doing the tables last week, you were telling me the rule in words. Some of you went ahead and did it algebraically, which is good. But what that rule means, it's saying that my output value, to get that, I'm multiplying x by 2, and then I'm adding 1. So I'm doubling x and then adding 1. So the first thing for part A, we're going to make a table, and then we're going to fill in the table. Okay, and then we're going to, for part B, they want us to look at the table to determine what are the greatest x and y values and what are the smallest x and y values. We need to know that so that we can make our graph. It says use this information to set up x and y axes that are scaled appropriately. We don't know what that means according to the ones that have already been turned in. So we're going to talk about what does this mean, scaled appropriately. Then we're going to take the values in our table and plot them onto the graph, and it says to go ahead and connect the points. Be sure to label your axes and write the numbers to indicate the scale. So I'm going to show you what I expect to see on a graph as we are working through these types of problems. So first is to fill in our table. So if my rule is y equals 2x plus 1, my first input is going to be -4. So that means if I plug -4 into this rule, what is going to be the output? So if I take 2 times -4 and then add 1 to it, what is the output going to be? What is the y value? So 2 times -4 is -8, and then -8 plus 1 is -7. I think I already wrote that in. So that's our first point. So when I go to graph this here in a minute, this is going to be my first point. My x coordinates -4 and my y coordinates -7. All right, looking at the next one, -3. So I'm going to plug this one in. 2 times -3 is -6, and -6 plus 1 is -5. Oh, excuse me. And then for the next one, I'm going to plug in -2. 2 times -2 is -4. -4 plus 1 is -3. Okay, so far, looking at my y values, okay, I know that my rule is doubling x and adding 1. But look at the y values. Do you see any kind of pattern down here? Do you see a common difference is what we call it? So if I take my values down here and I start subtracting them, do they have a common difference? So you can see here that we go from -7 to -5 to -3. So the common difference here is, hopefully you see it as 2. I take -5 minus -7, okay, that turns into -5 plus 7, which is a difference of 2. -3 minus -5, a difference of 2. So you can see here we have differences of 2. So continuing that pattern, for -1, if I add 2 to -3, that's going to give me -1. Now I can always take this -1 and plug it back into my rule to double check. So if I take 2 times -1, that's -2. -2 plus 1 is -1. So that works. So you could do either one. You can take your x values, plug it into the rule, to find your y, or once you start looking at these y values, and if you see a common difference here or a pattern here, you can continue it this way as well. So if you plug 0 in, we know that 2 times 0 is 0, 0 plus 1 is 1. 2 times 1 is 2, plus 1 is 3. And I'm going to go ahead because I know we're just adding 2 every time. 1, 3, 5, 7, and 9. So your table should look like this. Now, they wanted us to determine what are the greatest and smallest x values, what are the greatest and smallest y values. So if you look at your table, here's the smallest x value. It goes from -4 to a +4. So it goes from -4 all the way up to a +4. My y values go from a -7 all the way up to a +9. So when I get ready to draw my x-axis and my y-axis, I need to number them accordingly to what I have right here so that it fits all the values in my table. Okay, so now for the graphing part. You need a straight edge. So whether that's a ruler, if you don't have a ruler, just grab something that's straight on the edge of a book, notebook. And some of us forgot what a coordinate grid is. Okay, so we need to have an x-axis and a y-axis. You should have seen the example in 6-1 when you were looking at the redwood tree problem. If you got on that Desmos tool, that's a coordinate grid. Okay, there are 4 sections to a coordinate grid. I'm looking through the book to see if I can find one to show you. And there are 4 sections. You have quadrant 1, 2, 3, and 4. Here's an example here. Okay, so here's the x-axis. It's the horizontal line. Here's the y-axis. It's the vertical line. Okay, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. All the values, this is the origin. This is where 0 is. All the values to the right of the origin and above the origin are positive. All the values to the left and below 0 are negative. Okay, and remember, when we plot points, we always put the x value first and then the y value. So let's set up a grid or a graph that looks like this one. I want all 4 quadrants because I have positive and negative numbers in my table. If I had just had all positive numbers in my table, then I only need quadrant 1. But since I have negatives, I'm going to include all 4 of them. So let's go ahead. I'm going to go ahead and draw mine in there. It said to, in the directions, to label your axes. So when we're talking about the y-axis, okay, axis is singular, axes, A-X-E-S, that's plural form. Don't get confused. So this one is our y. The vertical line is the y. Let's see, okay. Then my horizontal line is going to be x. If this would help if I had graph paper. If you have graph paper, you may want to do it on graph paper. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right. I'm going to draw it right here. So remember, our greatest x value is 4. My greatest y value is 9. So this needs to at least go up to 9. I can count by 2s or however I want to do it, but I'm going to count by 1s. So let's see here. If I make this 0, 1, 2, 3, 4, 5, 6, 7, 8. My camera is pointing down to the table. They're not going to see you. My husband just army crawled behind me. I guess he thought that you all might see him. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see. 8, 7, 6, 5, 4, 3, 2, 1. Okay, so I'm going to draw my X right here. Now notice that I put an arrow. So these are like number lines. Whenever we're doing a graph, these are number lines. I'm drawing a vertical number line and I'm intersecting that with a horizontal number line. Number lines go on forever and ever and ever and ever. So the arrows, and I'm not going to draw a number line that goes on forever, or a graph. So I'm going to put this arrow here, and that indicates that this line is going to go on. So make sure that you have those arrows. And then this is the x-axis. You have to label x and y. Okay, that's part of a complete graph. From here, I need to go ahead and put numbers on it. So my x values need to go from -4 to +4. So on my x, these need to be as evenly spaced as possible. So this is going to be hard because I don't have graph paper, but if you are working on graph paper, it's going to make it a lot easier for you. But I'm just going to try to space mine as evenly as I can. 2, 3, 4. I'm going to just do one extra. Okay, so here's 1, 2, 3, 4, and 5. So I only need to go up to 4 because that's my greatest x value. But I went ahead and just did one more. Okay, same for the other side. I only need to go down to -4. So remember here in the middle, this is the origin, that's 0. So again, trying to make it as evenly spaced as possible because all numbers on number lines are evenly spaced. And again, I only need to go to -4. But I went ahead and just did one more just to make it look a little nicer. So my x-axis is ready. Let's look at the y. So on my y, I need to go from -7 up to +9. So I'm actually going to use these lines on my paper. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I don't have to mark every single one. Okay, you can if you want to, but I don't. 1, 2, 3, 4, 5. I just want to mark like that's 5. And then I'm going to do the same. Now I only need to go down to -7. Let's extend this a little bit longer down here. All right, so this is -1, -2, -3, -4, -5. Okay, that's all I'm going to put on there. Actually, for the sake of this graph and because we haven't done graphs before, let's just go ahead and label all the points. So I'm going to go ahead and number them all. Once you get used to doing graphs, you don't have to number every single little mark. Okay, so here's my graph. It's all set up. Some of you, I don't know what you were doing. You only had one quadrant and then your numbers weren't even in order. So remember, it's a number line. Your numbers have to make sense. If I got rid of this one and looked at just this x-axis, that's a number line. It has my negative numbers, my 0, and my positive numbers. Or I could look at it vertically. Okay, here's my number line. 0's in the center, it's the origin, positive and negatives. You need to have it set up before you do anything. A lot of you took this, not a lot of you, but those of you that have already turned in your work and I was looking at it, you took these numbers and you just put them on the lines. They weren't in any kind of order. So before we do anything with these values, we need to make sure our graph is set up and ready to go. All right, now let's start plotting our points. My first point is at -4. So my x is -4 and my y is -7. So if it helps, I'm going to write that out here. -4, -7. This is the ordered pair I'm going to plot. My next one's going to be -3, -5. Then -2, -3, -1, -1, 0 and 1, 1, 3, 2, 5, 3, 7, and then 4, 9. So these are all the points that I'm going to plot on my graph, and I got all of these by looking at my table. So you're looking at This is my first ordered pair, -4, -7. Here's my next one, -3, -5, -2, -3, and so on. All right, so plotting my first one, -4, -7, I'm going to go over to -4 on the x, because remember, the first one is x, and then I'm going to go down to -7. So over to -4, down to -7, and I'm going to put a point. There's my first point. My next one is at -3 and -5. Go over to -3, down to -5, and I'm going to put a point. My next one is -2, -3. Go over to -2, down to -3, put a point. -1 and -1, put a point. So these points should be in a straight line. Again, it's hard that I don't have graph paper, so it may be off a little bit, but they should be in a straight line. The next one is 0 and 1. So I'm going to go over to 0. I'm already at 0, so I don't need to go anywhere here. All I need to do is just go up to 1 and put a point. Then 1 and 3. So I need to go over to 1, up to 3. Over to 2, up to 5. Over to 3, up to 7. And then it's 4 and 9. Make sure this looks okay. All right. So my graph should look something like this. Notice that all my points are increasing. They're going up. And they're in a straight line. It's what we call linear. Linear. So the book said to, let me flip back, plot the points and connect the points. So we've plotted them. So now let's go ahead and connect them. Now, just because, this will let me know that my points weren't very straight. Just because the values in my table have stopped doesn't mean that the function, we call this a function, has not stopped, okay? So just because it stopped here in my table at 4, this can continue on. It can continue on forever if I wanted it to. So when you make your graph, please put these arrows here, again, indicating that this line could continue on forever. So arrows need to be on both ends of your lines. So I can't get that to fit in, so I turn it sideways real quick so you can kind of see it. But this is what your graph should look like. So part C said to label your axes. We did that by labeling it X and Y. We wrote numbers showing our scale. We counted by ones. If I had really large numbers, you might want to count by 2s or 3s. So you can skip count down here on your number line. That's fine as well. But when you go on to work on 335, please make sure that you are filling in your table and making a correct graph. And actually, one of the questions in 335 says, can you use this axes, this set of axes for the next problem? Which means, can you plot those points on the same set? Would this graph work? So really, you probably, let me see, 4 times 3 is -2. You could probably use this one. I don't know if I went up high enough on my values. If not, it might help that you just go ahead and sketch another one. Draw another one, that way you can practice. But again, for a complete graph, you need to have an x-axis, a y-axis. They need to be labeled X, Y. You need to have numbers. You need to figure out a scale that works with your values. We counted by ones. And we only went up to -5, +5, and then here I went to 9, and here I only went to -7. That's fine. It doesn't have to be the same. And then you plot your points that you were given in your table, and then you're going to connect your points. And then your graph is linear. Linear. That means it's a straight line. Okay, one more thing before I let you move on and finish up the rest of these problems. You only have 3 more to do. I want to look at the rule in this table and how they are connected. So earlier, when we were using the rule to figure out the y values, I was telling you to look, once you start seeing here, you can see if there's a pattern with all the y values, that they are increasing by 2 every time here. If you look in your rule, where do we see a 2? You see a 2 right here. Okay, that number tells me that my y values are going to increase by 2 every single time. This is what we call our slope. And we're not really going to be able to get into a lot of slope this year, but you will get into it next year. But I just kind of wanted to show you these connections. So again, all our y values are increasing by 2 as our x values are increasing by 1. So that means this number right here, the number that is in front of your x, is called your slope. Okay, and that tells you how steep your line is going to be. Now, this, I'm adding 1 every time, shows up right here when x is 0. So when x is 0, my y is 1. We call this our y-intercept. And we call this our slope. Okay, so our y-intercept is when x is at 0. So this is 1, and here's where it shows up right here. Our y-intercept. So what does this mean? How does that relate to my graph? Well, this number here is my y-intercept. So this tells me at 0 and 1 is where the line is going to cross the y-axis. So if I go back to my graph, notice right here at 0 and 1 is where my line crossed the y-axis. Okay, and then this number here, which is the slope, 2, tells me the difference in between each point. So if you go from, let's just start from the y-intercept. So if I start here, notice that my next point is 2 away. So I'm going to go up 1, 2. There's my next point. From here, I'm going to go up 1, 2. There's my next point. From here, I'm going to go up 1, 2, and over. There's my next point. Then I'm going to go up 1, 2, and over 1. There's my next point. So the slope tells me how far the distance is in between each point on my graph. Okay. So that's just kind of like to come eventually when we start getting into, well, we aren't going to get into it because we're not going to have time. But next year, when you start looking at more linear functions and slope and intercept. Okay, if you have any questions, you can send me a message, send me an email. You can get on Google Meet. I'm going to be on there between 12:30 and 1 o'clock. So if you want to get on there to ask a question, you can do that. But I'm not going to be doing like a whole group session. So if this was enough for you to understand how to do the rest of the problems, then you don't need to come to the Google Meet. So Google Meet, again, is just if you have a question about the work. If you don't have any questions, you do not need to come to the Google Meet. Okay, so I hope that helped. And again, reach out if you have any other questions.